Hello students, myself Dr. K.K. Mirji, Assistant Professor, Department of Mathematics, KLS Gopte Institute of Technology, Belgaum. Today in this video lecture, I'll give you some important tips on this continuity and differentiability. The questions which you people will face in the CET examination on this continuity and differentiability, for them I'll give you some important tips by taking some examples. So here, first example is if f of x is equals to sine of e to the power x minus 2 minus 1 divided by log of x minus 1 if x is not equal to 0, and f of x is k if x equals to 2. The value of k for which f of x is continuous at x equals to 2 is. That means we need to find, that is, for what value of k this f of x is continuous at a point x equals to 2. So now here we know that left hand limit is equals to right hand limit is equals to, that is, f of 2. That means the function at a point x equals to 2. So which implies that here left hand limit and right hand limit both are same, because for x greater than 2 and x less than 2 we have defined the same function. So therefore both LHL and RHL are same. So that's why we'll write limit as x tends to 2 f of x is equals to k. F of x is equals to k, because f of 2 value is k. That means f of x is equals to k if x is equals to 2. So therefore that value is k. So now here limit as x tends to 2, f of x is sin x into the e to the power x minus 2 minus 1 divided by log of x minus 1, which is equal to k, which implies that here you can see if you put x equals to 2 in this numerator, so that becomes sin of 1 minus 1, because e to the power 2 minus 2, that is e to the power 0, that is 1, so 1 minus 1 is 0, so therefore sin 0 value is 0. Similarly, if you put x equals to 2 in the denominator, that means log of 2 minus 1 is log 1 value is 0. So what we'll get is, that is 0 by 0 by 0 form. So if you get a 0 by 0 form in a limit, then we'll apply, that is L'Hospital rule. In that L'Hospital rule, what we will do is differentiate numerator separately and differentiate denominator separately. So if you differentiate numerator, that is sine of e to the power x minus 2 minus 1 becomes, that is cos first, that is cos of e to the power x minus 2 minus 1. Then chain rule will continue and e to the power x minus 2 becomes e to the power x minus 2 only, and derivative of 1 is 0. So that will leave it, right? And differentiating denominator with respect to x will get 1 divided by x minus 1. So it is, since it is in a denominator, so therefore it will comes to what, that is numerator. So therefore here you will get limit as x tends to 2 cos of e to the power x minus 2 minus 1 into e to the power x minus 2 into x minus 1, which is equals to k. If you put that is limit as x tends to 2, then here you will get cos of e to the power 2 minus 2, that is e to the power 0, that means 1. Cos of 1 minus 1 is cos 0. Cos 0 value is 1. And here e to the power x minus 2 is there. If you put x equals to 2, that becomes e to the power 0. Its value is again 1. And here x minus 1 is there. If you put x equals to 2, 2 minus 1 is 1. So therefore here it is 1. Therefore k value is 1 into 1 into 1. That is k value is 1. So therefore option D is the answer for first question. Next, the second question, here they have given, let f of x is equals to modulus of x minus 2 and g of x is equals to f of x, then g dash of x for x greater than 20 is. So here they have given x greater than 20. Very important, for x greater than 20, this x minus 2 is always positive, so that's why there is no need of writing this modulus. Directly we can write f of x is equals to, that is x minus 2. So therefore g of x is f of x, which implies that f of x value you can put here. So f of x value is how much? That is x minus 2. So therefore g of x is equals to f of x minus 2. So which is equals to f of x is equals to x minus 2. So therefore here we have f of x minus 2. So therefore what you will get? F of x minus 2, that is minus 2. So therefore f of x minus 4 you will get. If you differentiate now with respect to x, then g dash of x becomes, that is derivative of x is 1, we have written here, and derivative of 4 is, that is 0, so not necessary to write. So therefore g dash of x value is 1. So therefore D is the answer. So here we can say D is the answer. Next, the third question, let y is a function of x and log of x plus y minus 2 times xy is equals to 0, then y dash of 0 is. Here log of x plus y minus 2 times xy is equals to 0 is implicit function, and for this we need to find that is what, that is dy by dx at x equals to 0. So therefore if you take x equals to 0, then first we need to find that is y value, since it is what, that is implicit function. So you can find for x, at x equals to 0 what is the value of y we need to find. If you put x equals to 0 in this equation, so what you will get, this term totally 0, and here you will get log y. So therefore log y is equals to 0. So log y is equals to 0 means here y is equals to e to the power 0, that is equal to 1. So x equals to 0 and y is equals to 1 we get. So now differentiate this log of x plus y minus 2xy with respect to x, then we'll get, that is log of x plus y is 1 by x plus y, and chain rule will continue, and derivative of x is 1 and derivative of y is y dash, minus here product rule we need to apply. 2x you can keep first as it is, and derivative of y is y dash, minus 2y you can keep as it is, and derivative of x is, that is 1. So therefore this is the derivative of that's what the given relation. So now substituting x equals to 0 and y is equals to 1 gives. Why we need to substitute x equals to 0 and y is equals to 1? Because here we need to find that is y dash of 0. So therefore we need to put x equals to 0, and corresponding value of y also we need to put. So therefore now we'll get 1 divided by 0 plus 1 into 1 plus y dash of 0 minus 2 times 0, that means this whole term is 0 only. 2 into y is 1, that is 2 into 1 is equals to 0. That means here 1 plus y dash of 0 minus 2 is equals to 0 will get. That means y dash of 0 is equals to minus 1. So therefore y dash of 0 value is, that is 1. So therefore option A is the answer for this third question. Similarly, in the next question, that is question number 4, let f of x is equals to g of x plus g of minus x divided by 2 plus 2 divided by h of x plus h of minus x to the power minus 1, where g and h are two differentiable functions, then f dash of 0 is. That means we need to find this derivative of what, that is f of x at x equals to 0. So now you can see f of x equals to, first whatever they have given, so we'll write it. So they have given here, so therefore we have written the same thing here. Now you can see here, that is 2 divided by h of x plus h of minus x to the power minus 1. So in the denominator the power is minus 1, so therefore it will comes to what, that is numerator. So therefore here we'll get this one. So now differentiating this with respect to what, that is x, will get differentiation of that's what differentiation of f of x is f dash of x, that is equal to differentiation of g of x is g dash of x, differentiation of g of minus x is g dash of minus x into minus 1. So therefore here instead of plus, here it is minus sign, divided by 2 as it is, plus 2 times h becomes h dash of x, and h of minus x becomes minus h dash of minus x. If you put x equals to 0, so here you will get f dash of 0 is equals to g dash of 0 minus g dash of 0, because minus 0 value is 0 only, so therefore g dash of 0 we can write, divided by 2 plus 2 times h dash of 0 minus h dash of 0, that is g dash of 0 get cancels, and h dash of 0 cancels. So answer is, that is f dash of 0 is equals to 1. So answer is B. So B is the answer for this question number 4. Similarly, in the fifth question, if f dash of x is equals to sine x square and y is equals to f of x square plus 1, then dy by dx is. So very important, that is f dash of x they have given, that is sine of x square, y is equals to f of x square plus 1, x square plus 1 they have given. So given thing I have written. Next, take x square plus 1 as t, that is t is equals to x square plus 1, then y becomes f of t. Now differentiate this t with respect to x and this y with respect to t. That means t becomes dt by dx. With respect to x, if you differentiate, t becomes dt by dx, and x square derivative with respect to x is 2x, and 1 derivative with respect to x is 0, so you can leave it, and dy by dt, that means y we are differentiating with respect to t, so therefore dy by dt is equals to f of t becomes f dash of t. So f dash of t, that means f dash of x they have given, that how they have given, f dash of x is equals to sine of x square they have given. So therefore here f dash of t becomes sine of t square. So now we want dy by dx, not dt by dx or dy by dt. So to get dy by dx, what we need to do is dy by dt into dt by dx we need to do. So therefore dt get cancelled, so you will get that is dy by dx. So dy by dt value is sine square t. So dt by dx value is 2x. So first I have written that is dt by dx value, that is 2x I have written here, and dy by dt value is sine square t. So that is also I have written here, that is sine of t square. Sorry, not a sine square, that is sine of t square. So now it becomes 2x, keep as it is, sine of t value is x square plus 1. So therefore here you will get sine of x square plus 1 whole square. So the answer is 2x into sine of x square plus 1 whole square. Therefore C is the answer for this question number 5. Next, in the last question, question number 6, if f of x and g of x are two differentiable functions in open interval 0, 2 such that f double dash of x minus g double dash of x is equals to 0, f dash of 1 is equals to 2 times g dash of 1 is equals to 4, and f dash of 2 is equals to 3 times, and f of 2 is equals to 3 times g of 2 is equals to 9, then f of x minus g of x at x equals to 3 by 2 is. Simple question, it looks difficult but very simple. So first what they have given you can take, that is f double dash of x minus g double dash of x equals to 0 they have given, you can take it and integrate it. So integration of f double dash becomes f dash, in integration of g double dash becomes that is g dash. So I have sent this g dash toward that is RHS side. So therefore f dash of x is equals to g dash of x plus some integration constant c. Right, now putting x equals to 1 in this equation, will get f dash of 1 is equals to g dash of 1 plus c, which implies that f dash of 1 value is how much, that is 4. So therefore it is 4. G dash of 1 value is, that is 2 times g dash of 1 is equals to, that is 4. So therefore g dash of 1 value is 4 by 2, that is 2. So therefore 4 is equals to 2 plus c. So which implies that c value is, that is 4 minus 2, that is c value is 2. Now again that is put that c value is equals to 2 here and integrate this equation again. Then we'll get f dash of x integration is f of x, and g dash of x integration is, that is g of x, and c is 2. So therefore integration of 2 is, that is 2x, and some other integration constant k. Now put x equals to 2 in this equation, so that you will get f of 2 is equals to g of 2 plus 2 into 2 plus k. So f of 2 value is how much, f of 2 value is 9, and g of 2 value is 9 by 3, that means 3. So 9 plus 3 9 is equals to 3 plus 4, that is plus k, because why it is 4, because that is 2 into 2 4. So k value is again 9 minus 7, that is k value is 2. So if you put k is equals to 2 in this equation, then you will get, that is f of x is equals to g of x plus 2x, that is plus 2. So we want f of x minus g of x. Bring this g of x to this side. So therefore f of x minus g of x is equals to 2x, that is plus 2. And they asked us to find f of x minus g of x value at x equals to 3 by 2. If you put x equals to 3 by 2 in this equation, you will get f of 3 by 2 minus g of 3 by 2 is equals to 2 into 3 by 2 plus 2, that is equals to 2 to get cancelled, 3 plus 2, that is 5. So answer is, that is D. So D is the answer for this last question, number 6. Thank you. Hope it will help you for your upcoming CET examination. All the best to one and all. Thank you.